This is my chemistry project final. I did elephant toothpaste, and I hope you enjoy. So I'm adding 1 packet of active dry yeast to 120 milliliters of warm water. It will dissolve in the water and will act as a catalyst in my reaction. So it's going to take a little while to dissolve, so I'll stir it for a little bit and then I will let it sit for a couple minutes while it dissolves. Both of these cylinders are filled with 120 milliliters of H2O2, also known as hydrogen peroxide. This one will be the one that does not react with the 120 milliliters of water and yeast, and this one will. I will be showing them as a comparison. So, first we will need to add some of this lovely dishwashing liquid, so I will do that. It does matter how much you want to put in, depending on the size of the reaction you want. But you do not want to react with too much because if you react with too much, it can bubble up and spill out, which is what some people want. But right now I don't want that because I don't have anything to put it in. So, I'm going to add enough until I think it looks about good. Then I will add some food coloring. Adding the food coloring, if you want, it's completely optional. There's another one where you can add glow sticks, the inside of glow sticks, and it'll make it glow in the dark. But we're not going to do that today. We're just going to add some food coloring. So I will add some red drops into the graduated cylinder that will not be reacting with the catalyst. And then I will add some of the green food coloring to the beaker that will react with the catalyst. The food coloring not react with anything, so it's completely optional. It won't mess up your experiment or anything. So, for a comparison, they're both not reacting with anything because I need to add the water and yeast. So I'm going to set this one aside because it will not be reacting with anything, whereas this one will react with the water and yeast because the catalyst, which is this, speeds up the reaction because catalyst creates a lower activation energy, but it does not lower the activation energy. Because the activation energy is lowered, it makes it easier for collision to happen because the collisions do not need as much energy to react as if they would without the catalyst. So, this might not bubble out of the beaker. It will be very slow because this is only 3% hydrogen peroxide. Will most require 20 to 30% hydrogen peroxide, but it will work. So, here we go. So, this is what elephant toothpaste looks like, and this reaction is releasing the gas O2. And so what I will do is I am going to take a match and I'm going to light it. If I can. There we go. And then I'm going to light this small wooden stick. And then once I blow it out, so I'm going to try and connect it to these bubbles. And although it doesn't seem to be really relighting, it is glowing as bright as before because I did this reaction just a little bit late. This could also be due to the small amounts of O2 being released, because I only use 3% hydrogen peroxide while most use 20 to 30%. Also, you can see comparison of this beaker, or this graduated cylinder, with the catalyst versus this one without the catalyst. It did nothing. This is the balanced chemical equation that is happening in my reaction. It is the decomposition of H2O2 into H2O and O2. So this reaction begins to happen once you add the catalyst to the H2O2, and that breaks up into water and O2, which is the gas that was being released, which was helping keep the stick glowing for longer than it normally would. These are all of the sources I used throughout the entirety of the project. They were very, very helpful. So, in conclusion, that was my chemistry project, Elephant Toothpaste. I hope you liked it, and thanks for watching.